So we are officially entering what people are calling the agentic era. And what that means is we're moving from AI as a predictable tool to AI as an autonomous agent that can actually set its own goals. Now, this is a huge leap forward for sure, but it also completely shatters our old ways of thinking about software quality. So today, we're going to dig into a really important white paper from Google that asks a fundamental question. How do we build AI that we can actually trust?
Okay, so to really wrap our heads around this challenge, we need a new way of looking at it. Think of the software we're used to as a delivery truck, right? It's predictable, it follows a set route, and you check if it's working with a pretty simple checklist. But an AI agent, that's not a delivery truck. That's a Formula One race car. It's an incredibly complex system making split-second judgments on the fly. It isn't following a map, it's navigating a chaotic race, and you need constant, real-time data, telemetry, to have any idea if it's performing well. And that right there is the huge problem. You can't use the delivery truck's checklist on the race car. It just doesn't work. Our old methods for quality assurance are completely broken. An AI agent could pass 1,000 standard tests with flying colors and still fail, catastrophically fail, in the real world. And not because of a bug in the code, but because of a flaw in its judgment. So, how do you even begin to solve that?
Well, it requires a profound shift in how we think. We have to move away from what's called verification and towards validation. Verification is the old world. It's checking if the software was built correctly according to a rigid spec. The question is, did we build the product right? But validation, that's the new challenge. It's about figuring out if the agent is actually trustworthy and providing real value in a messy, unpredictable world. The question becomes, did we build the right product? It's a subtle but massive difference.
And the stakes for getting this right are incredibly high, because these AI agents fail in new and kind of sneaky ways. We're not talking about your typical system crash or an error message popping up. No, we're talking about things like factual hallucinations, where the agent just confidently makes stuff up, or algorithmic bias, where it starts making unfair decisions based on hidden patterns in its training data, or even what's called emergent behaviors, where it discovers a bizarre, unintended loophole to hit its goal. These are the kinds of failures that quietly chip away at our trust.
So if the old way is broken, what does the new way look like? Well, it all starts with another powerful analogy. This time, we're leaving the racetrack and heading into the kitchen.
Okay, so think about it like this. Traditional software, that's a line cook. They're just following a very specific, rigid recipe, step by step. An AI agent, on the other hand, is a gourmet chef who's just been handed a mystery box. They're given a goal and a bunch of ingredients, the user's prompt, some data, a few tools, and they have to improvise something amazing. With the line cook, you can just taste the final dish and see if it matches the recipe. But with the chef, no way. You have to understand their thought process, their technique, their reasoning. You have to understand the entire process to really judge the quality.
And this brings us to what might be the single most important principle in this whole paper, and it's this. The trajectory is the truth. What that means is the real measure of an agent's quality isn't just the final answer it spits out. No, the truth lies in the entire path it took to get there. Every thought, every tool it used, every decision it made. That whole journey, that is the trajectory. And that's what we have to judge.
Okay, so if we need to judge this entire trajectory, this whole process, how do we do it? What are we even looking for? We need some kind of consistent rubric, a critic's scorecard, if you will. And this paper proposes a framework that's built on 4 essential pillars that really define what good even looks like for an AI agent. This scorecard really broadens our definition of quality. First up, you've got effectiveness. The absolute basics. Did it actually solve the user's problem? Then there's efficiency. Sure, it got the right answer, but did it take 100 unnecessary steps and waste a bunch of time and money to get there? Third, robustness. What happens when things go wrong? When an API call fails or the data is a mess? Does it handle it gracefully, or does the whole thing just fall apart? And finally, the big one, the absolute gatekeeper, safety and alignment. Is it operating ethically? Is it staying within the guardrails we set?
So this framework is great, right? But it has one giant dependency. You can't judge efficiency if you can't see the steps it took. You can't figure out why it wasn't robust if you don't know which part failed. It all comes down to a really simple question. How can you possibly judge the chef's process if you can't see inside the kitchen?
So, how do we get that view inside the kitchen? The answer is a concept called observability. And this is way more than just your standard monitoring to see if a system is up or down. This is about building a transparent window, a glass box, into the agent's entire thought process.
And this visibility really rests on 3 technical pillars. First, you've got logs. Just think of these as the agent's diary, a timestamped entry for every single action it takes. Then you have traces. Traces are what weave those individual diary entries together into a coherent story, showing you the whole narrative from start to finish. And finally, you have metrics, which take all that rich story data and roll it up into that final critic scorecard, giving you the high-level numbers on performance.
Now, having this kind of setup allows for a really powerful 2-stage evaluation. You can start with an outside-in view. You treat the agent like a black box and just ask, did it work? What went wrong? But then you can switch to an inside-out view. You open up that glass box, you look at the entire trace, and you can understand why it went wrong. You can pinpoint the exact moment its reasoning went off the rails.
But you might be thinking, how on earth do you do this at scale? You can't have people manually reviewing millions of these complex trajectories. It's just not possible. And that's where this really clever idea comes in. LLM as a judge. The idea is you take another, more powerful AI model, you give it that detailed critic scorecard as a rubric, and you ask it to evaluate the quality of the other agent's process. You're essentially using AI to judge AI, which lets you get really nuanced feedback automatically across thousands of different scenarios.
Okay, so we have a framework for what good means, and we have the tools for observability to actually measure it. So how do we put all of this together into a system that is constantly improving? Well, the answer proposed here is a virtuous cycle they call a flywheel.
And here's how the agent quality flywheel works. Step 1, you define what quality means for you using those 4 pillars. Step 2, you instrument your agent for total visibility so you can see everything that's happening. Step 3, you evaluate its performance using a mix of those AI judges and human experts. And now for the magic part, step 4, you architect a feedback loop. Every single time a failure is found, it automatically gets converted into a new permanent test. So the system is constantly learning from its mistakes, which makes the whole flywheel spin faster and faster.
You know, when you really boil it all down, it comes back to one big shift in how we approach building these things. Quality can't be an afterthought anymore. It can't be some final step you bolt on at the end of the process. It has to be treated as a core architectural pillar from the very first day. Think back to that Formula One car. It's designed from the ground up with all those sensors and telemetry ports so that it can be observed. It's the same principle here. A truly reliable, trustworthy AI agent has to be evaluatable by design. From the very first line of code you write, you have to build it in a way that lets you see its process, judge its reasoning, and ultimately prove that it deserves our trust. Ultimately, what this framework gives us is a path forward. Because as these agents become more and more autonomous, as they get woven into the fabric of our lives, the ability to build, measure, and maintain trust, that isn't just a nice-to-have technical feature. It's everything. And the question that we all have to keep asking ourselves is, as these systems get more and more powerful, how are we going to make sure that they continue to deserve that trust?